Right, these 5 molecules we should be able to distinguish between. I don't have room on my paper, so I'm not going to do it, but you should have drawn out the structures of all 5 molecules. The point is that you need to be identifying the functional groups. So we're going to do it backwards this time. So have a look at spectrum number 1. The interesting peaks are this one, which we know is an OH. So we're doing this by looking at the data sheet. So this is at around 3,100 wave numbers. It's an OH, and I can see by looking at that is very broad. So that's going to be due to a carboxylic acid. But actually, even if you can't see that, you look over here and you can see that at 1,700 wave numbers, we have another peak that is our carbonyl peak. The combination of those two things means that this is a carboxylic acid. So that's going to be propanoic acid. The bonds that were important were our OH bond, we're going to say 3,100, and our carbonyl, which we're going to say 1,700 wave numbers. Next one down, number 2, interesting peaks. We've got this one, which is an OH group. See how it's less broad than that one. So that's an OH in an alcohol, and you can also confirm that by looking at the wave number. It's slightly higher. So we're now at 3,350. 3,350. This peak next to it is our carbon-hydrogen bond, so we don't care about that. And then we haven't really got anything else that's interesting, because remember, that's the fingerprint region and we don't care. So we're looking for a molecule that's just got an alcohol and nothing else of interest. So that gives us butan-2-ol. So apparently my phone cancelled my video halfway through, so I'll do it again. So we were up to number 3. So number 3, you can see there's no OH peak there. So we're not looking for a carboxylic acid or an alcohol. This peak here is your CH peak. So that's not very interesting. But what is interesting is this strong, sharp peak here, which at around 1720 wave numbers is clearly a carbonyl peak, C double bond O. So that means the molecule we're looking for is butanone. So the only one that's got a carbonyl peak, but nothing else. The next one down, I'll hide that from you. You can see we've got an OH peak here. So it's quite broad. It's actually sort of somewhere between these two, but you can also see the CH peak next to it. What we also have though is this strong, sharp peak of a carbonyl group at around 1,700 wave numbers. So usually when we have both of those, the first thing we would think is that this molecule is a carboxylic acid. But actually, because your OH peak is at around 3,400 wave numbers, that's too high to be a carboxylic acid. So what we're looking for is a molecule that has an alcohol functional group and a carbonyl group. So this is 1-hydroxypropanone. So sometimes it's difficult to decide whether your OH group is in an alcohol or a carboxylic acid. What I generally do is have a look and see if you can see the OH peak and the CH peak separately. That's probably an alcohol, like this one. Whereas if they've all sort of merged into one peak, that's more likely to be a carboxylic acid. But sometimes you have to rely on other information as well. So that's that one. The last one, we know what's left. We can see it's 2-methyl-but-2-ene, so it's an alkene. We're only looking for the CC double bond. This peak here is a CH peak. It's really strong, you can see it clearly, but it's not very interesting. What we're looking for is that double bond. It's really small, that one there, which is at around 1680 in this one. It's really difficult to see, so you'd probably miss it unless you knew you were looking for it, which luckily in this case we do. So that's 2-methyl-but-2-ene.